So yes, hi, my name is Miranda, and I am an associate editor for Springer Nature, specifically the journal Nature. So but before I get started, quick question for all of you. How many of you have published a scientific paper before? Quick show of hands. All right, excellent. And how many of you know about Nature and kind of what it is and what it does? Great, that'll make my talk a lot easier. So first and foremost, we're going to answer a couple of questions with our presentation today. The first is, what is primary research, or primary science? And this is what goes into Nature. This is your scientific articles. And the second is, what is secondary content? And the definitions are, and then we're going to say, how are they the same? How are they different? And finally, what are some general writing tips that you can use for both, or that you should use for either? So first is a little bit about Nature, which thankfully a lot of you have heard of. It is a scientific publication that publishes predominantly primary research, but we do have a portion of the journal that does do some secondary content. And some notable accomplishments of the journal is that we published the Antarctic ozone hole, the first report of carbon nanotubes, Dolly the sheep. We really do specialize in papers that attract a wide audience and that should wow other scientists. So first, primary research is what I've been talking about. This is something where you report data. You have your data, you are presenting it for the first time. Your secondary content is writing about data that maybe either you or somebody else has already reported on, or you're synthesizing new research avenue or new ideas from data that's already been previously reported. So things that they have in common, they both, in some ways, usually convey the results and their implication. Who cares? Why? Second, they are usually geared towards at least an educated audience. Typically, most of our readers at least are college educated. Third, they all benefit from clear and concise writing, and this will be the same for pretty much any writing you do ever. And finally, they need great motivation. No matter what you're writing and in what format you're doing so, you always need to answer the question, why should your reader care? So next, let's talk about what they do differently. So when you read a paper, just quick show of hands, how many of you start with the introduction? How many of you just look at the figures whenever you read a paper? And how many of you actually read the abstract, the results, the title, and the conclusion in its entirety? So you'll see that whenever we're talking about primary science, some of us tend to care more about certain parts of the paper than others. So whenever you're writing primary research, you really do need to keep in mind all of these audiences and how this will affect how you present each part of your paper. Now compare this to a newspaper article or a blog post. Do you ever start at the end of a blog post? Probably not. So this will also change the way that these types of works are structured. So first, I'm going to start with secondary content. I know that we've seen a lot about science communication today and with the public. In most cases, this will be secondary content. How to write a science story. So I'm going to go over this briefly because we've talked a lot about it today already. So first, types of secondary content. I think that we've covered this quite a bit, but briefly, science biographies, summarizing research, opinions on research topics, tutorials, but also reviews and perspectives, things that would be published in Nature. These are secondary science articles, so long as they are not presenting new data. And of course, there's a million other types like tweets, etc., which we've also talked about today. Next, next I do have kind of a 5-step program for how to write, which will be the same for any format which you're writing in. And we've talked already a lot about this today, but the first rule is always 100% of the time, pick your audience. This is always going to matter. Is your audience other scientists, or is it experts in the field, or is it stakeholders, or your grant funding agency, or whomever? This is going to be the #1 thing that determines how you write your article. Second that you have to do, step 2, is are you reporting news or sharing an opinion? Now, the trick is that in most cases, you will be sharing an opinion, even if you don't mean to, and even if you really want to just report news. And I say embrace this because there's going to be a huge difference, even in a very simple headline, between 10,000 people died, 10,000 people were killed, or 10,000 people were murdered. The information is almost the same, but the way that this makes us feel and the way that the wording kind of enhances the picture in our minds is completely different between this very simple change. And I do say embrace this because if your writing is hesitant, if you aren't clear with what you're trying to say, this hesitance will be visible to your reader, and it'll make your writing feel kind of tepid or weak. And you do want to avoid this whenever you're writing, especially secondary science articles. Third, pick a length. This is very simple. Secondary science, you have a lot of flexibility. Somewhere between a tweet and a novel. Fourth, this is also quite important, assert your message. What do you want people to know? And there are a couple of questions that you're going to answer with this. What do you want people to know is the first. How will it benefit them is a big question. And third, what do you want people to know? Which is sometimes different from what do people need to know, especially whenever we're incorporating our opinion. And once this is done, it's time to build your narrative. This is one structure for a narrative. Has anybody seen this structure before? Yeah, it's basically, it looks kind of like this. This is one way to structure a story, which is quite simple. You start with your exposition, which is your setting, your background. You set up the questions that need to be answered throughout your piece. Next, you have your rising action, which is where you build suspense, and you have some conflicts that happen along the way. And then you have the climax of your story. This is the turning point. This is where all of the conflicts are resolved. And then the falling action is how we answer the remaining questions till finally we have a resolution in which no more questions need to be answered. And the important thing about this is even whenever you're writing a research summary is that readers really like to feel clever. So the idea is that you want to set up a series of questions in a reader's mind, and then they can maybe guess a little bit, and then you want to answer them. You want to give the satisfaction that their answers that they have come up with in their minds are maybe reflected in what you're writing. And this is especially important if you're writing a research summary or research highlight, as we call them in Nature, for example. So pro-writing tips. This is the first, biggest, most foremost tip is get to the point quickly. You always want the important information first. And this will be things like who, what, and where. That is the first thing that should be in your sentence. Second is additional info that is helpful but not crucial. That's the why. And third is the nice to have. This is things that usually come at the end of whatever you're writing. And this is, again, the most crucial rule, not only whenever writing papers, but also in structuring sentences. So, and this will always supersede the next tips. So next, of the technical tips, we have active voice. And this is very important, especially whenever we're communicating in English. What this means is that you want your subject to do the verb. You don't want the verb being done to them. So the example here, I say, instead of a human patient underwent surgery performed by a robot, you say, a robot did the thing. However, this will be superseded by the last rule. Always get to the point quickly, even if you have to use passive voice. So if you can't tell from my accent, I am an American. But as an American, I would never say, a bear mauled President Biden. You would always say, President Biden was mauled by a bear. Even though that's passive voice, the important information in this sentence is probably the president. Next technical tip is pace. This is varying your sentence length, varying formal and informal writing, and this is what will really give your writing your voice. This is how you insert your personality into what you're doing. And third, and my favorite rule, and one that I will drill into everybody, this will come up several times in this presentation because I believe in it so much, is use shorter sentences. I cannot stress this enough. No more than 20 words per sentence if you are writing in English, and no more than 1 or 2 points in the sentence. You don't want to have a paragraph be one sentence. And in fact, one-word sentences are okay. One time, Nature published a research highlight or secondary science article that started with a one-word sentence. That one word was bollocks. So it's also okay to be a little bit provocative and fun as long as it carries your point across. And so just a quick summary of what we talked about here with secondary content. We have the 5-step program, structuring narratives, and then some pro tips. So next, let's talk about primary research. And this is how you wow your audience. So first, 5-step program is the same. Think of your audience. However, whenever you're writing a scientific article, your audience tends to be other experts. You have your scientists, you have the reviewers, and you have your editors. And a quick overview of how this process works whenever you write a scientific paper is this diagram. So you'll see that once you submit your paper to the journal, it will undergo an editorial decision. The first decision determines whether or not it gets sent out to peer review. And then if it gets sent out to peer review, now your audience is the referees, who are experts in your field. And then once it gets through the referees, it'll come back to the editors, and then you present it. The journals typically are presented for other scientists. So this is the audience that you will basically always have whenever writing a scientific paper. And this changes things. For your intent, rule number 2, is pretty much always going to be reporting results. And for this, then the key thing is you want to explain, don't hype, because this will always anger your referees. So you want to avoid overselling your work with hyperbole. And this is just an example of hyperbole. You want to avoid terms of primacy, like novel, new, for the first time, etc. Again, this will make your referees typically very angry. The next thing, well, yeah, is avoid claims of novelty. It's quite important. Next, pick a length. Unlike secondary science, research articles tend to be a bit more specific, and you typically want your research paper to be between 4 and 10 pages, with up to 4, maybe 5 figures. In asserting your message, you always want to say, see why this is important. And this is something that tends to get lost in scientific articles because we want to be very precise, very specific, very rigid. And we tend to say, see what I've done. But that does not convey the importance of your results. We really want to show, see why this is important. And some tips to get started is read papers you like and find accessible. Avoid a descriptive or chronological writing style. You don't want to have too many adjectives in a row. It tends to sound like a list. You want to guide the reader through your story with a clear structure and logical flow. And I'll go into this logical flow again because it's very different from a narrative flow. And finally, make sure the significance is clear. And shorter sentences, again, every time. And finally, this is one that's not super clear whenever writing science articles, is that we want to avoid jargons and acronyms, especially uncommon ones, whenever possible. And I'll also get into this a little bit again later because it's very important. So building your story structure, I did mention that I would talk a little bit about logical flow. Here's some examples of a story about somebody who wanted to bake an apple cake, but they went to the supermarket and didn't have any apples. So you'll see in the first one, it says, I wanted to bake an apple cake. I went to the supermarket, but they were out of apples. So I bought pears and baked the cake. Pears can be a suitable substitute for apples in a cake. You might have read some scientific papers that sound like this. Second is my supermarket has a shortage of apples, which is problematic for baking a cake. In this work, I show that pears can be a suitable substitute for baking a cake. And finally, third, no apples? Try a pear. When my supermarket was out of apples, I thought surely my baked cake would be ruined. Desperate, I used pears instead. It was delicious. So, I have some numbers here, and I want to ask you guys, which one of these is a narrative? Number 3? Number 1? And which one of these has a chronological flow, the order of which events happen? Number 1, which means 2 is our logical flow. And what this does is it sets up the problem and then solves it. And this is what you want your scientific papers to do. Thank you for participating. Now I'm going to go through a scientific paper in parts and talk about how to write in such a way and to structure each of these important parts of your paper. As we already determined, different readers read. So figures, title, abstract, that sort of thing. And your title is really supposed to draw the reader in, but in this day and age, we also need to optimize it for the search engines. So you want to make the main message clear, be descriptive, not too detailed, avoid language like novel and new, because it won't be very novel for very long if other people then build off of your work and you get a million citations. And avoid too many adjectives. This is a big one. This title up here is a mouthful, and nobody really wants to write a title like this one. And finally, use keywords to enhance discoverability, but don't make it a list of buzzwords, which does tend to happen. And finally, don't use uncommon abbreviations and acronyms because it will make your paper difficult to understand and difficult to search. And I did talk a little bit about the jargon and acronyms, but I really want to drive this point home. This is my favorite New York Times article ever written, and it was published in 2020. And it's titled, "Are You Confused by Scientific Jargon? So Are the Scientists." And this is a graph of the number of citations a paper gets versus how much jargon is in the title. And as you can see, the number of citations exponentially decays. And even though, as scientists, citations are not the most important metric, but it is one that people use in order to, use funding agencies and et cetera, et cetera. And this is especially important for interdisciplinary work. If you work between chemistry and material science, for example, different concepts may use different jargon, which can be quite frustrating if you're trying to find your work. And interestingly, this is also true for your abstract. The more jargon you use in your abstract, the less likely people are going to be able to search it, and less likely they are to be able to understand your paper. Which brings me into the abstract. So some pro tips in the do's. Make the question you address clear. Make the question you are addressing to be clear. Summarize your most important findings. Mention any critical methodology. And by this, I mean truly critical. You don't want to give the methodological details in your abstract because you simply don't have space for it. They will read it in your methods section. And finally, you want to note the implications of your work. Answer that, why do we care, immediately in your abstract. And don't provide detailed methodology, as I mentioned, the uncommon abbreviations and acronyms, as we just learned, and specifically reference figures. Especially if you publish an article behind a paywall, your reader might not be able to see your figures. So if you reference them in your abstract, it's very likely that your abstract doesn't make sense whenever it's being read on its own. And at Nature, we do have an abstract formula. So the first is 1 or 2 sentences about the introduction to the field or the background that's comprehensible to a very broad audience. And then 1 or 2 sentences stating the problem being solved, that logical flow. And then 1 or 2 sentences summarizing the main results, question, answer. And then finally, 1 or 2 sentences explaining how the main results adds to previous knowledge. Or 1 sentence putting the results into a more general context for a broad audience. And this would look something like this. And this is a paper about coastal flooding due to growing population. And then it says, however, the problem. And then very important words whenever you are telling about the solution to the problem that you are setting up is the here we show. In this work, we. And you want to make this very clear in your scientific papers. And then finally, they show that doing whatever they did in the study is important and why people should care about it. And this ends again in a very broad scope and geared towards a broader audience. Next, we have your introduction, which introduces your question. And In doing so, it sets the background, and as we saw in the abstract, we move from the more general, like very broad audience, down to the specifics of what we did in this work. And eventually, we want to make that question very specific. And then about citations, it is good to make sure that your work is properly referenced. If your work is improperly referenced, it will anger the referees. But it is good to be selective. Especially if you work in a very crowded field, maybe 1 or 2 seminal works instead of having 150 citations for your one paper. And finally, you want to summarize your findings briefly. Again, that very important here we show, and in your introduction that will be a paragraph that goes into a little bit more detail than your abstract. Next, we have your results and discussion. This is the heart of your paper. This is what most scientists will at least read if they read beyond the abstract, and it really shows what you did. This is where your experiments and your results, the data that you're presenting goes. And again, logically, not chronologically, this is so important. I have repeated myself several times on it. 2, include essential methodological detail, enough to understand what you did, but not necessarily enough to reproduce the paper because that belongs in your methods section. Use headings to guide the reader. So in your results and discussion, you can say this is the characterization, this is the whatever, this is this, and then you can create the structure of your story through these headings. And then finally, discuss relationships to previous work, especially if this is in your discussion. You can contextualize your results and note the limitations and see where this kind of slots into the scientific record. Next is your figures. This is your data on display. And as we mentioned previously, sometimes this is the part of the paper that gets the most attention. And with this, there is a #1 rule, and that #1 rule is always clarity. Clarity is always more important than beauty. Your figures convey information. It is helpful if they are beautiful, but the information should be clear first. Second, as with results, they should also be presented in a logical order. And then finally, well, not finally, but a very important detail is that you want to keep them focused. It's very confusing whenever you have one figure that has 15 panels and then 4 layers of subpanels, and it takes up a whole page. I think that that really would not be a very clear figure to see what you've done. So I would avoid doing this. You really only want to present one single concept per figure. And finally, you can use diagrams for complex ideas or methods, particularly for like these schematics. I think that that's very helpful. And use the caption to explain what's in the figure, usually in about 150 words. So this is the primary research article summary. So we do have the same 5-step program. It's in a logical flow, writing an abstract, and then a research article. And then I do want to conclude with comparing. So for primary research, this is usually always a research paper, and it gets published in a scientific journal or on the archive if you tend to use this. You want to make clear the contributions. Your audience is the experts. And you want to convey and contextualize the results and implications. The organization is logical. And the level of scientific detail, ideally, should be enough to replicate the work. And this is quite a lot of detail often that you have to include. And whether or not you can hype or add a little bit of pizzazz, please don't. In a scientific paper, I think that the level of opinion should be minimized. And compare this with secondary content. This is the news articles, highlights, blog posts, anything written about research papers, anything that you would read in a pop science article. And where is it published? Anywhere. Twitter, Phys.org, wherever you find science writing. And the purpose is usually quite different from primary research. Often it can be to teach, to inform, to persuade. Sometimes just self-promotion is a reason to do science writing. And your audience is usually educated non-experts, but of course this can change, and as we learned, you can tailor this accordingly. And the goal is to make the results digestible for non-experts. The organization is a narrative flow. And the level of scientific detail is really only enough to understand the main points. So for example, whenever you're doing scientific writing, typically in secondary content, the methods are quite scientific and maybe don't add much to your main point. So this might be a way that you could construct your secondary content. And as for the level of pizzazz, as I call it, or opinion, some is usually good. And I just wanted to kind of conclude this talk with a kind of a plea, a call for action. Please help me. Please make your work searchable. And also, please make yourself searchable. It is very, very helpful for both editors and referees and journalists if they see a great scientific paper, if they can contact you. And typically, your university website will have your email, but we have to be able to find you and find which university you work for and then go onto the university website in order to find your email. This takes a lot of time. And if you are interested in being a referee for the Nature portfolio, and I'm trying to contact you, if I can't find your email address and your expertise in less than 2 minutes, I'm probably going to pick somebody else. And I think that some of the best resources that you have at your disposal is, of course, your university website or your company website. Make sure that your email is available online. Second is Google Scholar. That is a very good tool. You can make a profile. You can pick some keywords. If I look for photonics, will your Google Scholar profile come up? That's very helpful. Twitter, as we mentioned in the other talks, or Mastodon, Facebook, Instagram, wherever. And then if you do publish scientific papers, having an ORCID ID is incredibly helpful. And so that does conclude my talk. I did kind of fly through this, so if you have questions, I'm very happy to answer them.
Thank you so much, Miranda. Perfect. So while we have you here, we definitely have some questions. And my most burning question that I believe is likely on the minds of many people in this audience is that a lot of people here probably would love to see themselves in nature. How does that practically happen? What does that application process look like?
Okay, that is a great question, and I did not go into the editorial process here today because this was about science writing, but as a Nature editor, what I am looking for, and this is the same for any journal, not just Nature, is who is going to care about your work? Is it your very specialized community? Is it all of people who study photonics, which is more broad? Or is it every scientist ever will read your paper and say, that's really cool? Depending on who your audience is going to be and how you place your work into the context of the scientific record is going to determine where your paper goes for its final home journal. And for a Nature paper, there is a ton of very good, well, Nature, I should say, is a showcase journal. It really aims to showcase the best in the field. There is a ton of very good science that does not make it into Nature because even though it's amazing science, it is not the showcase. And so if you discover something that you think is incredible, please do submit it to us. I would love to see it.
Now, is that in the form of an email? Is that sending over an abstract, a pitch email?
Once you prepare your scientific paper, you go on to nature.com, and there will be a tab that says For Authors. And then it says For Authors. You can say Submit My Paper. And there is kind of an interface, a UI, where you submit your paper, and it'll ask you things like your name, your ORCID ID, your university affiliation, the other authors of your paper, your abstract, and then you upload either a Word document or a PDF LaTeX file, and it'll eventually make it to my desk or one of the other Nature editors.
And what is it that will pique your interest?
So for me, my remit is photonics, electronics, 2D materials, devices, telecoms, applied physics, and engineering. So I think most of the science at this conference would be in my personal remit. If you do have a cool project and want to ask me about it, please find me.
And what's your red line? Like, no, this isn't for us.
That's very hard because Nature only has an 8% OTR rate. So there is a lot of, like I said, very good science that perhaps is not going to make it into Nature. However, some common mistakes that I do see would be mountains of data that don't address the question of why should we care, which is very sad because it's very easy to accumulate data, but if it's not enabling in a certain way, or if it doesn't open up new research avenues, then perhaps that's not a Nature paper, even if it was still a ton of work.
Got it. Thank you so much. So opening it up to the audience, we have Mikkels.
Thank you. That was super interesting, and I hope I will receive at some point the slides, or I will see the recording of your presentation. But my question is sort of, could you maybe give some insights on how do you think which are the major trends in academic publishing at the moment? Sort of, there has been a lot of debate regarding predatory journals, and then there's those lists where they are saying that these aren't, and there are sort of these things that are changing, and which are your top list of what's happening?
So there is a major trend in academic publishing, which I'm sure you guys are all aware of, is moving to open access. This is a very large change in the academic publishing industry and very similar to journalism. If a lot of the revenue streams of scientific journals tend to be subscription-based, and if whenever we move to open access, this is obviously going to have to change. In terms of the predatory journals, simply the rate at which science is being published is higher than it's ever been, and it's exponentially increasing. And to accommodate this, tons of journals are launching. And one of the hallmarks of a predatory journal is if you have to pay upon submission. If they say, we'll take your paper, but it's X fee in order for us to assess it. That's usually a red flag. If you get invited to review for something that is completely outside of your scope of expertise. For example, I am a photonics editor. Sometimes I get emails inviting me to referee clinical studies. I've never done biology in my life, but I guess my name and my email is on the internet somewhere, so I get invited. And outside of that, look for journals where your peers publish. You know, if you trust the people around you and you are excited by their work, and their work is accepted into a journal, you can usually trust that that journal is somewhat reputable.
We have our next question from Anda.
Thanks. So you already mentioned mistakes a little bit. Can you tell a bit more? What are the biggest and the most common mistakes you see in the papers you receive?
I feel like oftentimes and this is a good thing because it means that there's many aspects to the paper, but I think oftentimes the novelty or the advance that the scientist is excited about is perhaps not the most exciting facet of the paper, which is always very interesting as an editor because I'll say, oh, I love this, but your introduction is all wrong, which does happen, rarely, but it does happen. Another mistake that I see people make is that if they claim something that isn't well established. So, for example, a lot of people here are optimizing for things like cost. If you tell me that your photonic platform is cheaper than the silicon available, please show me. I'm not just going to take your word for it. Or if you say that it has better performance and it's only in simulation, it's probably a more compelling paper if you actually have done the experiment and can say for sure, yes, this is a thing.
Perfect. Do we have any other questions from the audience? No, here we go.
I wonder, can any researcher become an editor of Nature, or you need to be a special one?
It is a very competitive job market, but in theory, anybody can. The thing about Nature, which is different from other scientific publishers, is that all of our editorial decisions are made by full-time editors. So there's two types of publishing models. One in which you have full-time editors like myself who are paid by the journal, and this is my full-time job. All I do is make decisions every day. And you have other types of editors who are called editorial board members, who are full-time scientists who assess maybe 3 to 10 papers a month. But really, their job is a scientist. They are an active researcher. So if you are an active researcher, I'm sure that there are plenty of journals who would love to have you on their editorial board. It is something that a lot of people use, for example, in their tenure applications. It's very helpful to say that you've contributed back to the scientific community in this sort of way. And if you are ready to put down your lab coat and go into scientific publishing, if you still want to be a part of the scientific community, you can become an editor. The criteria is that you at least have to have been an active researcher at some point, and typically this means that you have a PhD. It's also very helpful if you've done a postdoc and or were a professor at some point, but the bare minimum is active researcher at some point.
Great, thank you. Any other questions from the audience? No? All right. Well then, another round of applause to Miranda. Thank you so much for sharing your experience.